All right, so we'll talk about this Pascal triangle and how do you construct it. First, you start with a 1 and you do a couple ones to make a triangle like that. And then the next line in the triangle is built from the one before. So for example, here, I'm going to put a 1 at each end. And in between these two guys, I'm going to put their addition. So 1 plus 1 is 2. So I get, right here, I get my triangle. Next row, I do a 1 and a 1 at the end. And then in between these two guys, I put their addition. So 1 plus 2, 3. And here, I put their addition, 3. Next time around, and 1 at the end. 1 plus 3, 4. 3 plus 3, 6. And 3 plus 1, 4. And so forth and so on. And let me do one more without saying much. Just write it out quickly. And you can continue like that. Let's call this one n equals 1, first level. This one will be n equals 2. This is the 0 level because you start counting at 0. And I see that my numbers are not showing, just the index, so it's okay. That's my level 5. And you can continue on like that. So that is Pascal's triangle. And what is it useful for? So if you wanted to do a plus b squared, you go to your n equals 2 right here, and that gives you the coefficients 1, 2, 1. And so what do I multiply here? I start with the square of the first one. Then I subtract 1. I go down 1 in degree from a squared. So I get b. Now I'm going to fill from the other side. I'm going to start here with b squared. And when I move to the left, I'm going to subtract 1 in degree. So I was at b squared here. I'm going to get b. And that's typically, or that's what you remember as your formula for foiling this squared. Let's try the cube. So my coefficients would be 1, 3, 3, and 1. And I start here with a squared, a cube rather, my bad. Let's erase this quickly. And here I'm going to finish with b cubed. And what I'm going to be doing is I'm going to be subtracting 1 degree in degree here. And when I move to the next, I subtract 1 by degree, and I get to 0. The next one, I subtract 1, subtract 1, and I get to 0. So this right here gives me a way to write the cube without having to compute it out. Now you can see that you can do a plus b to the 4th just using those coefficients, but now let's just write it out. You get a to the 4th plus the first coefficient is 4. You drop degree by 1, and if you want, you can increase the b by 1. Then I get 6, subtract 1, increase 1. Then I get 4, which is my next coefficient. Decrease 1, increase 1, and let's see if I can still fit it. The last one is just 1, which is b to the 4th. Perfect. All right, so right there you see how you can compute. Now, if you wanted to do an a plus b to the 5th, you just follow these numbers. And this is a lot faster than trying to FOIL it out or whatever. But how does it work? Let's kind of try to track what is happening when we would have this a to the 4th and we wanted to compute the 5th. A plus b to the 4th, sorry. And we want a plus b to the 5th. So what's going to happen is, for example, let's just track one of the terms. I want to think about the term, let's do, say, a cubed b. how can you get an a cubed b, a cubed b squared? They all have to add up to 5, right? You see everything adds up to 4 in the exponents because you're computing a quartic there. All right, so how can I get a term here from this expression above? Remember, a plus b to the 5th is a plus b times a plus b to the 4th, right? So firstly, let's locate where would this guy appear. This guy would appear in our list, would appear with this coefficient if I were just to compute it with the Pascal's triangle, because you start with a to the 5th, a to the 4th, a cubed. So that guy would be, we hope to get a 10. And how does that happen? Well, whenever I FOIL this out, I'm going to be multiplying this expression here times a plus b. How can I get an a cubed b here? Well, I can get 1 when I multiply b times a cubed b. So I can get an a cubed b squared if I multiply b times that. And b has a coefficient of 1, so that's going to give me a 4. And another way I can obtain a cubed b squared is if I multiply this guy times a. So this guy, a has coefficient of 1 here. When I hit this guy, it gives me a 6. So what I'm doing is I'm grabbing the addition of these two guys above and putting it in front. That's where I get my 10, from grabbing the ones above and adding them together. That's how Pascal's triangle works. Because every time, if you want to compute this one, the degree that would correspond here, which in this case would be the a squared b squared, can only come from a squared b or from ab squared when you multiply times a and b. So that's how you get those coefficients. But this is a very easy way for you to FOIL or to expand an expression of this form, a plus b. And you say, I never need a plus b. Yeah, but you do need things like x plus 1 to the 5th and things like those. So that's one quick way to do it, and that's called Pascal's triangle. And there's a lot of combinatorics that happen in Pascal's triangles. It's a very interesting topic. So maybe in the future we do a few more.